Everybody make it back? All right. I never know. Okay. So I have this question to go over from Appendix G. That's the one about synthetic division. It's way in the back, right before the answers section. By the way, when you get a math book, you should always see what the hell it tells you. So I always look at the front cover and the back cover. The back cover, they got some geometry formulas and stuff. Front cover, I think they ain't got, well, they got real math for the real world. Oh my God. Counting tweets. Yeah, right, that's a reach. So this one is number 8. Okay, what is it about number 8? That gave you trouble. Who asked this question? Did I dream it? Oh. So what's the trouble with this? How do you set it up to start with? What do you put in here? This is the one you're asking about, right? The number 8?
I just have 2 answers, but I don't know what I
So how did you set it up?
For the answer, for one of them, I got 2x plus 3x minus 8, and then negative 25 over. I saw like the example in the book.
Sure. But you must have set it up, right? I mean, how did you set it up?
X plus 3 divided by.
Yeah, so this is that.
But
it says use synthetic division, right?
I don't know how to do this.
Oh, all right. So somebody else help me out. What do you put in the little... Yeah, so we put the opposite of this, and that's related to changing the sign first, instead of changing the sign every damn time, right? And synthetic is beautiful. It says, as long as you got everything in the right order, you can just pull off the numbers, because they're really the only part that matters in the work. At the end of the thing, you better put the x's back in. But what are the coefficients going to put down here? 1? 0, good, because we got no x squares. 1, negative 2. Kick ass.
How did you get 1?
There's a known 1 there. Right?
Okay.
There's a known 1 there. And the 0 is because I have no x squares. Is that right? So the coefficients of the top is in order. It's in descending order. So I can just take the coefficients off of those.
Oh, that's how you're doing. You're taking the coefficients?
Yes, because when you do the long division, you start to realize that all the x's are what makes it a long problem. Why do I keep rewriting all these stupid x's? When it's really just the numbers that matter. So if I did this long division, I would put, what would I put here?
X squared.
X squared. Why is it a 1? X squared, because that's a 1 and I want a 1, so I'm going to put a 1, right? So that's related to why I can just drop this down. That's going to be the coefficient of the first part of the answer. Whatever that number is, it's going to be the first part of the answer. Now what do I do with that 1 x squared? I multiply it by this. Now why is this unnecessary? Because it's going to be the same every damn time. So why would I want a process that makes me write all the shit out that I really don't need to, right? And then x squared times 3 is plus 3x squared. So I did 1 times 3, and I got 3, but then what do I have to do right after that for long division?
Switch the sign.
I've got to switch the sign. So this says, screw that shit. Let me just do 1 times negative 3 and get there right off the bat, right? So here's 1 times 3 is 3x squared. Change the signs, and now I do 0 minus 3, so here I do 0 minus 3. So see, this just focuses on the more important parts of the problem. I like it. If you do a few of these, you should get the feel of it down, right? Which is why I assigned a few to do. 0 minus 3 is negative 3. So over here, what do I get? Those are canceled. 0 minus 3 is negative 3. Bring down the x. What do I put here? X goes into negative 3x squared minus 3x, right?
See, I'm getting that same answer, but I did it long division.
I love it. The only bad part for you is it says you have to use synthetic, right? So on a test or something, if you get the right answer, but you got it a different way than what I asked, you're going to lose all or maybe most of the points, right? So here, what would I do now with this? I would do negative 3x x is negative 3x squared. Negative 3x times 3 is negative 9x, and then I would change the signs. So here, just again, negative 3 times negative 3 instead of negative 3 times positive 3. I've already got the sign changed. I hope to God you guys are kind of with me. You start to see how the idea of math is to try to make a process that you do over and over simpler so you can do it really quickly, right? Negative 3, negative 3 is 9, and then you add. So here, I would change the signs. Where do they go? Negative 3, and I already changed the signs. Good job, Jeff. And there I get 10, and here I get, there's my 10. Okay. And you just keep going in that fashion. Let you have a little bit left over to do. What would this be the coefficient of in the answer?
X squared.
Yeah, it'd be 1 less than this because you're effectively dividing by x. So you're going to have 1x lost in each term. It's going to be 1 degree less in the answer. So this would be x squared minus 3x plus 10 plus something. Whatever the remainder is, yeah. I like it. Cool. Maybe. So definitely in the appendix, you could do long division if you want to, but then you better follow it up with what it tells you to do, the synthetic. You got to do the synthetic division. You want to do another one of those? Yes. Okay. Yeah.
12?
Oh, well, let's see. I'm not going to do number 12, but I'll tell you the thing people don't realize about number 12 is how many things are missing. What am I going to put in the little box for number 12? Negative 1. And then I got 1x to the fourth, 0x cubes, 0x squares, 0 x's, and 1. Okay. And then you attack it the same way we did this. You have to put the zeros in placeholders for what's missing. They're not really missing. They just have zeros as coefficients. You have to put all the coefficients down, right? So you're not really adding things in. You're just putting what the coefficients are. Is it cool? And then you attack it the same way we just did this one.
Can you attack it?
I can. You help me out. What goes here? 1. You bring that down. Whatever this is, you bring it down.
Okay.
And then you multiply, add. Multiply, add. Multiply, add. Multiply, add. I like it. Now the process is pretty simple. You just got to do a few of them to get it. It's deceptively simple. Your brain says, this ain't math because it ain't hard. We'll tell your brain, screw that shit, brain. Math ain't supposed to be hard all the damn time, right? It isn't. Believe it or not. Okay, so just accept that it's not that bad. Now, if the remainder comes out to be 0, that means that that can be factored. This one shouldn't. Maybe it would. I don't think so. Maybe. I don't know. It would mean that it would be factored, and no, it wouldn't be. This one shouldn't come out to be 0. We talked a little bit about that yesterday. Do you have to know that going into this? No. This is just pure straight up, do you know how to synthetically divide? It's just a tool. I like it. If you're going into, those who are going into calculus eventually, this is going to be a stupid useful tool. Pre-calculus, holy shit, you're going to use the hell out of this thing. Okay, if you don't have to do any of that, then you got to be able to do at least this for me, right? Yep.
I'm just making sure my math is right because you said there's no remainder on that one.
Let's see. I wouldn't think so. No, there shouldn't be.
So if it's 0?
1,
Oh, yeah.
1, negative 1, negative 1, 1, 2, yeah, yeah. If the remainder does come out to be 0, that means that that can be factored as this times something. It means it goes in evenly. Same way with numbers. What's it mean when you have a remainder 0 and you divide numbers? It means that that number went in evenly. No remainder means it went in evenly. I like it. So just to really hammer that one to death, 42 divided by 6, will there be a remainder? Because 42 is 6 times 7. So if there's no remainder, that means that that could actually be factored into this times something. This one, that's not going to happen. But I just wanted to remind you of that fact. The remainder actually means something. The remainder means more than that, and you'll learn that in pre-calc if you take it. Okay. And the crowd goes, all right, whatever, man. All right. Anything else from anything else that we've done so far? Yes? 16? Oh, 16 is a little gross because, and they want to show you an example of, this is kind of related to what to do if the first number is not a 1. You know, I can divide by this, but if it was this, I couldn't really do it. But what makes this 0? Negative 1/2. So I could actually use negative 1/2 here if I'm careful. Again, that's beyond what we have to do for this class. But just in case you're curious, there are things you could do. This one doesn't start off that way. It starts off a squared plus a over a plus 2.5. All right, and you're like, damn problem. What are you going to put in here then?
Negative 2.5.
Negative 2.5. This is what I desperately am trying. I've started teaching this way in all my classes, teaching the process. I care that that's a freaking negative 2.5. The process doesn't give a shit. You still bring it down, multiply, add, multiply, add. The process does not change. I'm like, oh, decimals, really? But the process is like, do this. Okay, maybe. The thing that really trips people up the most on this is not the 2.5. It's the fact that the top is missing something and they forget to put a 0 there. You guys see how it's missing a constant term? Oh, shit. So that's my big hint to you is you should do this. People stop too early in that problem. You're missing a constant. You've got to put a 0 there. Okay. All right. Anything else from homework stuff? You guys look appropriately oppressed. Okay. Okay. If there's nothing else, we're going to get into chapter 7. I'm going to lecture on some, we're going to review what we did last time. We'll do some new stuff, and then I got a little group worksheet that you guys will work on. Then we'll do a little bit more, and then we'll get the hell out of here. All right? So last time, believe it or not, we got up through 7.2. We got into 7.2. So just to review a little bit. How do I do this? What values of x make 4x minus 2 over x squared minus 11x plus 30? Undefined.
So you want to factor that out.
Good, factor it so you can see the parts.
So it would be x minus 6, x plus 5.
Careful now.
Minus 6, minus 5.
Yeah, they both have to be the same sign, and so they both have to be negative. I like it. And then most of us should be able to just see this. What makes this 0?
6.
What makes that 0? So what values would make this undefined is anything that makes the bottom 0, 6 and 5. So if you say like this, I'm fine with it. X can't be 6 or 5. Is that? Please let that be decent. Here's a nifty one. Here's a little bit evil one.
Nothing.
Yeah, why nothing?
Because anything that's squared plus 1 can't be 0.
I love it. If you square something, it's going to be at least 0, right? Square a real number. Let's just be careful if you know complex numbers. We're dealing with real numbers here. Any real number squared is going to be at least 0. 0 squared is 0. Negative 1 squared is 1. 1 squared is 1. Oh, shit. And then I add 1 to the damn thing. So is there any way the bottom could ever be 0? No. Do you guys see that? The smallest that piece could be is 0, and then I'm adding 1 to it. So what's the smallest the bottom going to be? 1. So can the bottom ever be 0? No. And if the question is listing all the values that makes the bottom 0, then what values make it undefined? No values. What values am I allowed to use? All values, right? Nothing. Nothing makes it undefined. Right? Same thing with this. This one is a little bit freakier. I get the weirdest answers on this. What values of x make that undefined? Again, undefined means, can you make the bottom 0? Well, what is the bottom no matter what the hell you do? 7. The bottom is 7. What if x is just 7? What if x is negative 8 to 7? Right? So can you make the bottom 0?
No.
So, no. So what values make it undefined? No values. Nothing. It's always fine. It's always 7 on the bottom. You guys see that? There's a problem like that, I think, in the homework. So I want to give you a little heads up now. All right. How we feel about that? Is that decent? So there is a little bit of a usage of factoring to help us see that. So factoring is going to be throughout this chapter 7. Then we got this kind of thing. What you got, Jeff? Sure. All right, so remind me, just tell me, how, simplification. What would you tell the person that started to cancel some y's out and they said, oh, look at this, 3 goes into both of these? What would you tell that person? All right, and you have to factor first, but can you tell them why what they did was wrong? They might go, I don't want to. Can't I just, 24 over 27, I know what to do with that. What the hell's wrong with this Jeff dude, man? He's weird. He's weird math ways, whatever.
Because of the negatives?
Well, sort of.
You can't.
Because of the pluses and the minuses.
Yeah.
Division is what you're trying to use to cancel stuff, and the only operation division can cancel is multiplication. And then I got a bunch of freaking subtractions and additions. It ain't never going to work that way. But your brain just looks at it and goes, let's make this look better. And you're like, whoa, shit, no, we can't do this. So yes, you must factor first. I love it. So how do you factor the top there?
Y minus 8 and y plus 5.
Good. The bigger one's got to be negative.
Positive 5.
Plus 3.
3. Yeah.
And then the bottom is going to be a who to what? The thing that you guys were like, oh, we didn't put one on the quiz, thank God. Now, if you did a cube on the quiz, oh shit, you shouldn't have because there wasn't one on there. All right, so I give you a little more time to get used to cubes. So what do I put down here? Just
Y plus 3.
a little too big deal. Humor me. And this is y. This is 3. Little dude gets
Y plus 3.
y plus 3. I like it.
Y squared.
Y squared. And at the end I put,
No.
I like it. Good. Minus, so it can do its job.
3Y.
3y.
Negative 3.
Bam! And now I can see, does something cancel? Between the top and the bottom? Does anything cancel?
The Y plus 3.
Yeah, whatever number this is, it's the same on the top and the bottom. So that can just go the hell away. All right. So I get y minus 8 over y squared minus 3y plus 9. Bam! Whatever the hell that is.
Where do we get the negative 3? Negative 3y.
Oh, okay, so the middle term is got to be the cleanup guy. He exists just to clean up all the other shit I don't want. So I really want you guys to see. Y times y squared is by y cubed, right? 3 times 9 is by 27. But I also get 3y squared. Am I supposed to get 3y squared? No. And I also get, where am I at? Plus 9y. I don't want 9y. So what's he do? Y times negative 3y is negative 3y squared. Kills that piece. 3 times negative 3y is negative 9y. Kills that stupid piece I didn't want. So that's why he's always the opposite sign of this. And what works is the product of these. That's what makes the other ones cancel. And again, that's one of the least liked forms of factoring. Unless you start to realize, once you just do a few of them, you just get the pattern. It's a pattern that you have to use. Squares you can kind of sink your teeth into. This problem you can sink your just working with numbers and getting them to work right. You can sink your teeth into it. This one you just got to memorize where things go. Okay, maybe. So the bigger idea here, though, is if I have a rational expression, oh shit. So remember, a rational number is one that can be written as a fraction, right? Ratio, right? Rational number. Rational expression is just a ratio of expressions, a ratio of polynomials in this case. So if I have a rational expression, I might be able to reduce it the same way I do numbers. Okay, maybe. All right. So then here's the next level. That's where we left off yesterday. So we did that. Somebody help me out. Remind me, what do I do with something like this here? How do I do that?
Multiply the reciprocal.
Yeah, so then I say 4/9 times, and we actually, I don't know if you remember, I showed you why that works, why that's true. Right? It's not just the thing we decided to do, it's a thing that has to happen. So that's what we do. And then I can do what? I'm not going to do 4 times 27, dear God. Right? You don't want to make these huge numbers that you didn't have to work with. No. Kill them first a little bit, right? Yeah, exactly. Cross reduce. 1/4. 1/3. 1 times 3. 1 times 4. So you get 3/4. I like it. Now, unfortunately for you, that's Math 88 shit. You ain't going to see that. So it's going to tell us what to do with a problem like this that I want you to do right now. Oh, crap. Now I got to actually make it already. All right, let's see. Ooh, yummy. So do that problem, and just to make sure you guys all start off on the right foot, since this is divided by, the first thing you should do is flip that dude. Bam! I like it. So go ahead and give that a try. I'll shut up for a little while. Bless you.
Thank you.
So one thing you do if you have any trouble with what I call bookkeeping. So sometimes a problem is so big that some people have trouble keeping keeping track of the parts. You can actually do like each little piece of this as its own little problem and then put it back in. All right, so that's what you could do. I'm not going to do that right now, but if you needed to, you can take each part and kind of do it. This obviously has a damn thing you can do with it, right? So let me see if you guys are able to handle. You would flip this over, and then you would factor. So how do you factor the top here?
7A.
Good. 7A comes out. A minus 2. The bottom, of course,
A plus 2, A minus 2.
A plus 2, A minus 2. Times, so on the bottom here would now be 7A to the 5th. And how do you factor the bottom here? A minus A minus 2. I like it. So no, I didn't make a mistake. Hopefully you guys caught this. And sometimes this is another mistake people make. Once something cancels, it's dead. Right? It's dead. It's not a zombie. It can't kill something else. So what happens with these A minus 2s? So what happens with that A minus 2? Anything? Nope. It's still there. Can't cancel this because they're not the same. What else cancels?
The 7A is 7A.
Yeah, the 7. And then 1A cancels. How many will I have left down here?
4.
4. So you can start to see how your answer is going to be all the survivors, right? So the messier you are, the easier it will be to forget some survivors, which really sucks for them, right? You want to make sure everybody, don't leave anybody behind, right? So what do I got up on top? I got nothing here. I got this and this up on top. And what do I got on the bottom here? Yeah, A plus 2 times A4. So A4, A plus. We normally put one term dudes as coefficients, just so they don't get lost. Poor little guys. Cool. How do you guys feel about that? Maybe that's one bad question. You guys get that? I get it, but I hate it. All right. I want you to realize that this problem is really the same thing as the problem we just did. It's just more stuff. Whatever's on the top and the bottom can die. Kill each other. I like it. So what if it doesn't start off as division? Well, then you do the same thing we just did. You don't flip that. That's beautiful, right? So if you can do division, you can do multiplication easy. Just don't flip the second dude. You guys? So it's a bunch of factoring and then killing what's common. That's all that problem is. So again, going back to what I said before, if you can't factor, you obviously can't do this problem. Right? Okay. All right. So here's some new stuff. And this is semi-new. I had a problem like this on that warm-up sheet. This is from section 7.3, which is a very funny section to me. I mean, if you read the title of 7.3, you should go in knowing it's going to be pretty easy. Addition, subtraction of fractions with like denominators already. Well, shit, yeah. Even if there's variables there, I almost don't care. So, for example, if I had x squared over x minus 4 plus, what you got, Jeff? I don't know, man. Let's do negative 6x plus 8 over x minus 4. Yeah, that'll work. So the first step will have to be easy. There's just no other way around it. That's one place where I feel completely comfortable saying that. What are you allowed to do here? Just put them together. I like it, right? Because they have the same denominator already. Denominator. Now, please, dear God, what would you tell the person that does this? Don't do that. What would you tell a person?
It's a common denominator. So
It's common denominators. Now, nowhere am I multiplying those guys. So why would there be a squared there all of a sudden? Or you can do an example like 2/5 plus 1/5 is not 3/25, right? Bam. And now, what do I have to do? Now that part's done. Well, whenever you're dealing with fractions, what's always the last thing you look at? Can it reduce? Can it reduce? Oh, shit. Right? So those problems are easy to begin with, and then they become this kind of stuff, right? This one's not that bad. How do you factor the top, or can you?
X minus 4, X minus 2.
I like it. And then, of course,
Cancel.
x minus 4's go away. So the answer is just x minus 2 kick ass. Now, to me, I always think, somebody always says, like, oh, all that shit becomes that. I'm like, that's awesome. I took all that shit and made it become that. These are equivalent. These are the same thing, except for what? What's the one value of x that this wouldn't work for?
4.
Yeah, I had to almost give it away in the question. Yeah, 4 would make this shit to begin with. You guys see that? So that's the one value of x that this does not apply to because it makes it undefined to begin with. But every other value of x, this is true for. So if you put a 7 in here and did the work, it would become 5. 7 minus 2 would become 5. Okay, maybe. Okay, God, I can't read some of you guys at all. Okay. All right. So that basically captures all of 7.3, to be honest. There is one thing. Let's do a couple examples with this, because this is where people make the biggest mistake. So that sounds like a good thing to look at, Jeff. What if I had, let's see, still 7.3. X over x plus 7 minus 3x plus 2. Let's make this minus 3x minus 2 over x plus 7. Can anybody pick up on the part of this problem that makes people make mistakes? Which minus? Yeah, this thing right here. Because people will write this. Do not write this. People will write x minus 3, x minus 2. That's wrong. That's wrong already. That's wrong. What am I subtracting? I'm subtracting this. So it's got to distribute. You can see that. So this should be plus 2. Okay, cool. So just be careful. You know those negatives, wherever they are, they could make trouble. There's a few different ways to look at this. I mean, if you have a lot of trouble with that, you could always make negative plus a negative, right? And then you remember to bring the negative 1 through. I mean, that's a little wonky to me, but if you're having a lot of trouble, then you can do that. And now, of course, what's this become? Yeah, negative 2x plus 2. And will that go anywhere? I mean, you can factor the top, but would you? It's never going to become the same as the bottom, so screw it. I know I'm done. You can't reduce, so I know I'm done. All right, how's that? Is that all right? Okay, some of you guys look sick. I'm sorry. Don't do that. There's the door. Okay, so if I'm you, I'm like, what the hell am I going to do when the bottoms are not the same? Oh, shit. All right, so let's remember what we do when the bottoms are not the same, when it's just numbers. That's always what informs us what to do when they're variable expressions. Because they do the same damn thing. I really do. So what if I had, turn this way. What if I hired somebody to be my photographer person, video person? So this is 7.4 now. Recall. So what if I had this? 4 over 27 plus, what you got, Jeff? Say 5 over 33. I like it. That's awesome. That's yummy. All right, let me show you a process. I don't know if you've ever been shown what I'm about to show you. So one way you could do this is to pick one of them and just start 27, 54, just start counting by 27s. All right, that gets quickly not easy. That's not normally 3, 6, 9. Now 27. So screw you. It's not something I can just rattle off, right? So there must be a better way. And the reason I teach this, what I'm about to show you, I teach to my Math 88 students, is because it's something that's going to work for us when the bottoms are gross variable expressions. It's exactly the way I'm going to have to do it then. So here's what I do. The whole idea of LCD is to give something to somebody that needs it to build it up. And when you give it whatever the other guy has that it doesn't have. That's the idea. If you think about it, that's what LCD is. So first thing I need to see is what the hell do they both have? Well, what's the biggest number that goes into both? 3. I like it. 27 is
9,
3 times 9. 33 is
11.
3 times 11. Now I can see exactly what they're missing relative to the other one. It's sort of like if any of you have kids, you give one kid ice cream and another ice cream, you put sprinkles. The other kid's like, yeah, sprinkles. I want sprinkles. You put some sprinkles. Yeah, more sprinkles. And I used to joke that I would probably be a horrible father because I would just take both and eat them both and say, nobody gets ice cream except me. And now all of a sudden I have kids possibly. Anyway, so I got to see what I'm going to do when I give them ice cream. So what's he missing that he's got? 11. So you give him an 11. It's crazy. What's he missing? He's got 9. So you give him a 9. It's crazy. Has anybody ever seen that before? Does it make sense even if you've never seen it before? I mean, that's, now do you see how both the bottoms are the same? What are they? 99 times 3 is 297. All right, how did I do that so quickly? Because 100 times 3 is 300. 99 times 3, right, is 1 less 3, so it's 297. Okay, so I get, what do I get up here? I get 44 over 297 plus 45 over 2, that's kind of nifty, equals 89 over 297. Sweet. And then I don't know if you guys remember, obviously 3 goes into this, right? If you start to think about trying to reduce this, 89 doesn't have much anything go into it, right? So this looks like these are not going to go anywhere. Are you guys cool with that idea? Okay, so this is Math 88 shit, right? So let's look at what we're going to have to do. And we're going to do exactly the same thing I just did here. Notice, of course, where this comes in, this is going to be factoring an expression now. So I'm going to have something like this. Let's see. Whoop. So now I've got, say, 4x over, that's not making an x, sorry. Let's not go there yet. X squared minus 9 plus 3 over x squared minus 7x plus 12. I like it. So let's do this one together. Now, no matter how much I say the process to use, I'm going to have somebody tell me the answer is 7 over 2x squared minus 7x plus 3. Where did that person get that answer?
He added the denominator.
He had just added everything. Right? He or she, I don't know. Right? But we know better than that. We know that we cannot add fractions unless they have the same denominator. We know that. But your brain goes, there's x's, everything changes. No, they can't. There's just numbers. So screw that. Don't do that. So, of course, what's the first thing I do? Same thing we did here, right? Fact. I like it.
X minus 4, X minus 3.
I like it. All right, so that step, everybody should be able to factor those. And now you can see relative to the other one, what's the other guy missing, right? And don't feel like that's wrong. I mean, I want you to, that is relatively simple. If you're able to factor, these are easy. Let that be true. So what's this guy missing?
X minus 4.
Yeah, he does nothing 4, so he needs an x minus 4. And he's missing,
X plus 3.
yeah, x plus 3. He's got the x minus 3, he doesn't have the x plus 3. So I better give that to him before he starts crying. Okay. Now, a couple things. If that was a minus, I always tell people to do, like I said earlier, put plus and then you put a negative on the 3, so you remember it's got to distribute. That makes it a little bit easier. But that's not a minus, so that's no problem. So on the top, what do I get? I get
4x minus 16.
plus
3x plus 9.
3x plus 9. I like it. All over. Bam, bam, bam. That is the LCD. That's what ends up on the bottom. I like it. And then the top, I just simplify it. What do I get? I get just something range. 7x minus 7 Now I can factor the top, but would it reduce with anything?
No.
No, so I'm done. I get an x minus 1, and that's not on the bottom, so it wouldn't go anywhere. So I'm not going to do that.
There probably will be a lot of times though when you can factor that and then cancel out from there,
Exactly.
right?
So you should always at the end
Look for that.
check to see, because the book is going to make it so that that happens
happens,
sometimes. Yeah. I like it. Okay. Maybe. So let me do this. Let me finally shut up for a little while. Let me give you this here.